Hi and welcome. We're going to discuss power series today. Okay, and we're just going to touch on the basic idea of power series. And we've seen some examples of power series before. So, for example, this summation from n equals 0 to infinity of 1/2 to the n. This is going to be 1 plus 1/2 plus 1/2 squared, and so on. And we saw this is a geometric series. It converges to 1 over 1 minus 1/2. Okay. But power series is more general. Power series is when instead of having a 1/2 in your series, what if I did this? I had x. And so the example above here, this is a specific example where x is equal to 1/2. So instead of having this converges to a number. This thing is going to be 1 plus x squared plus so on. This converges to a function. And this sorry, this second example is an example of a power series. Okay. So we're now no longer going to be dealing with numbers in our series, but we're going to have variables. And there are two questions associated with this. So let me write them down. So the first question is, to what function does the series converge to? So in our example, it converged to 1 over 1 minus x. That's what it represented. And we're going to discuss this question, but it's not going to be the very first question that we're going to be centered on. So kind of the presentation that we're following of the material is reversed. The other question is that this function, if you plug in any old value of x, like x equals 2, this series doesn't converge. It'll be equal to infinity. So, because this is a geometric series, it only represents the function 1 over 1 minus x when x is less than 1. So the second question is, when can we represent the series by the function? Okay. We're going to have to be proficient at answering both these questions, but the focus for now is on answering the second question. Okay. So let's answer 2 here. I mean, after all, we already found what it represents. And the answer to 2 is typically going to be a ratio test or a root test combined with another test for convergence or divergence. Okay, so to answer 2, I'm going to use the ratio test. Okay. Here, a sub n is just going to be x to the n. So a to the n plus 1 is going to be x to the n plus 1. And the ratio test says compute this limit as n goes to infinity of an plus 1 over a sub n. Okay. Well, we plug that in. We're going to get absolute value of x to the n plus 1 over x to the n. And we're going to get this absolute value of x that doesn't involve n at all, so it is its own limit. So the limit is absolute value of x. And this is the limit. That's L. Now we can see by the ratio test the series converges to 1 over 1 minus x when and maybe I should put this wording up here so I don't have to write it up here every time. By the ratio test, the series, well, it converges if the limit, which is absolute value of x, is less than 1, i.e. absolute value of x means that x is bigger than minus 1 and less than positive 1. That's just how the absolute values work. So here we'd say the radius of convergence is 1 and it's centered at 0. Because if I have 0 here, right, here's going to be 1, here's going to be minus 1. And look, it converges if I go a radius of plus 1 in either direction. So radius is equal to 1 and the center is equal to 0. Okay. 2, it diverges outside of this. So if here's 1 and here's minus 1, I'm going to dash that. That diverges there. Diverges by the ratio test, it diverges if absolute value of x is bigger than 1. Okay. There's a third statement. If absolute value of x equals 1, i.e. x equals plus or minus 1, then use another test. Then no info. So use another test. Okay, well, I'm going to investigate plus or minus 1. Okay, and let's take this third step a step further. This is the part where if you're using the root test or the ratio test, well, you need to try another test. So let me just plug in x equals 1 into the series. If x equals 1, the series becomes 1 to the n. And once I checked, anything to the 1 power is 1. So, this is going to say when n equals 0, I get 1. When n equals 1, I get 1. When n equals 2, I get 1. And so on. This only gets bigger and bigger, so that's infinite. That diverges. So it diverges for x equals 1. Okay, if x equals minus 1, well, this is the sum from n equals 0 to infinity, and this is minus 1 to the n. This is a divergent alternating series. Okay. So the interval of convergence is this. the interval of convergence is for x strictly bigger than minus 1. It can't equal it because we get the divergent alternating series. And less than positive 1, we get a divergent series as well. Okay. And when x takes on a value between minus 1 and 1, well, what we've discovered is that we can represent this series next to 2 as 1 over 1 minus x. They represent the same thing. Okay. Well, thank you very much. This was an introduction to power series.